Hi, my name is Aditya. I'm the CEO of Automatski. Today I'm going to be talking about the quantum circuit compression world record that we think we have beaten. But let me give you a brief background about what's happening in the world of quantum circuit compression. So frameworks like Qiskit, Penny etc. come with their own quantum circuit optimization algorithms which optimize for gate depth, etc., and also for targeting a specific hardware native gate set. Now, till now, Qiskit had a built-in optimization engine, and recently they have launched Qiskit function, which is basically a cloud-based service which can optimize your quantum circuits using AI. But in quantum circuit optimization is a very competitive space. And this is where the most cutting edge algorithms of compiler design and come into play. Now, in October 2025, QMill, a company, announced that they have broken the record in quantum circuit compression. This is the article from the Quantum Insider, and they had a benchmark circuit which you know they reduced from 71 gates to 24 gates and 928 gates to 740 gates, etc. And they released three uh, files for the circuits so that you could see that they have reduced the gates, and they were utilizing the IBM gate set CX, RZ, SX, and X gates specifically. Now, also in continuation to that, this is from another article, and now QMill has said that they achieved a compression from 4,200 gates to 1,600 gates in just 1 hour of classical compute runtime. The competitor, like Queso, required 24 hours of computation to achieve 1739 gate result. Now, QMill has trained an AI model, and AI models are supposed to be fast. This brings us to the first problem. Currently, even the best quantum computers outside Automatski can probably run 5,000 gates or similar. And Automatski's quantum computers can run millions of gates and hundreds of logical qubits. But in a production environment, a real quantum circuit that solves a quantum chemistry or a finance problem, etc., might run into hundreds of millions of gates. So if you are telling me that you processed 4,200 gates and reduced it to 1,600 gates in just 1 hour, and the next best competitor took 24 hours of compression, then probably your algorithm is not useful at all. First of all, trained AI models are supposed to execute very fast. And because I'll tell you the problem. The problem is if you have 100 million gates, then you would require 100,000 times, 100,000 hours to compress that circuit. So, one of the things in quantum circuit optimization is to optimize for the execution time of the result also. And mind you, these two are the top contenders in the quantum circuit optimization space. And they also claim that, with 48 qubit implementation of 99.94% accuracy in reduction of quantum circuits with that tolerance, their benchmarks indicate it can outperform El Capitan at 1.7 exaflop supercomputer. See, the supercomputer will take 2 to the power 48 sized vector to store the Hilbert space or the state, the simulated state. If you reduce the depth of the circuit or the gate count, you are going to reduce the duration of the simulation, but not the difficulty of the simulation. So, anyway, now it is like I said, you have to have methods that are lightning fast. And if even AI with reinforcement learning and gigabytes of quantum circuit training data is not useful if it takes 1 hour for a thousand compressing a thousand gate circuit. Now, what I have here are very small examples. I'll run them concurrently just to show you that they're very light on the CPU and they are running locally. So I'm running a random benchmark with 5000 gates and 12 qubits. And the reason I'm doing this is because random circuits have no structure inherently and they are the most difficult to optimize. So on the other hand, I will run a benchmark with the QMIL example specifically, which the article mentioned. Okay. Now you see here on my left hand side for a 5000 gate circuit, we we got a 41% reduction. And remember, this is a random circuit. You are supposed to you this is supposed to be very difficult to optimize, and the execution time was 14.4 seconds. These guys are talking about hours and 24 hours and days. Okay, now you see the benchmark here, the qmil benchmark. I'll not read this out, but I'll go to the table below. This is the original loaded circuit gate counts. This is the original gate counts, and this is Qual. Qual is another, top contender in the open source for quantum circuit compression. It compressed it to 50. We compress it to 51. QMIL did 24. Here, Qual did 821. QMIL did 740, and we did 689. We beat them. This is supposed to be a very difficult circuit. It's a Galois field 2 to the power 8 multiplier circuit. And the other circuit, we were close by. But now the problem is you are not supposed to have any pre-knowledge of the examples. And you cannot select a target gate set that you know will do well with those examples. You are supposed to use target gate sets that correspond with the hardware backend. And I'm on this left hand side. I'll pause for a second. I'm running a 20 qubit 100,000 gates benchmark. And while we continue, so Stonefish, the product from Automatski, makes absolutely no assumptions or pre-knowledge of the structure of the problem. It has a pipeline that works on arbitrary gate sets, and we have actually omitted hardware native target gate set optimization from the front end quantum circuit optimizer. Now, why do we say that uh, this is what QMIL has done, and why do we say, and QMIL is supposed to be the best in the world? Okay, QMIL and Queso and Qual, these are supposed to be the best in the world, not those vendors like Penny Lane, Google, and IBM, etc. These are the top contenders by a large margin. And why we say we have broken all the records in quantum circuit optimization, because Automatski has its own hardware quantum computers and quantum annealers. And this is a known fact that Automatski's gate-based quantum systems support hundreds of logical qubits and millions of gates even today. And our annealers support 500 million qubits or binary variables. And the annealers run in seconds. Now, why this is important? Because you will look at this demo and say you guys are close enough, right? But what you get in addition to this is that you have an Automatski SDK where you have this front end algorithm which can be plugged in, and you can get all this optimization. And the SDK works in 25 programming languages, and you can use any vendor quantum computing framework to program and define your problems in and execute it on our hardware, Automatski hardware backend. Now, we are not in the space of enabling execution on multiple hardware backends, multiple non-Automatsky hardware backends, because we have no interest in that. We want the entire world to use any programming language or any vendor framework and execute on Automatsky's backend. So what we have done is, what you don't see in this benchmark is that there is a counterpart that we have in our backend middleware that does a further optimization of the quantum circuits that reduces the already front end reduced quantum circuits by 20% to 60%. And that's that's phenomenal, because what you end up getting in totality, you are getting around 39-40%. You can look at this, 100,000 gate random circuit reduced by 40%, and time taken is 153 seconds. That is nothing compared to hours and days that these guys are talking about. Now, in apart from this 39, 40, or 50% or whatever you get on the reduced 50% circuit size, you are going to get another 20 to 60% reduction. So if you see in totality, we have beaten this game by miles. And that is why what I wanted to tell all our prospective customers, that when you work with Automatsky, you are in good hands. That's all I had to show you today. Please let us know if there is any way we can help you out. And if you have any questions, please feel free to email us. Thank you very much.